Thanks, guys. All right, so real quickly, since we're talking about dependencies, I had the question, what do I mean when I say dependencies? And so what I mean by that is, in your local development environment specifically, you're going to have for your project some set of dependencies, whatever language you're working in, you're going to have your package manager, and you probably have those dependencies installed locally, and it's probably you've had days where it's a nightmare getting those things straight. So we're going to talk about how Docker can make your life easier in that arena. Being that, oh yeah, and by the way, some of the examples that we're going to go over are at this link. So if you haven't, I posted this link in the Meetup event. So if you haven't already, you can go ahead and check this out. Go ahead and, if you have your computer with you, just go ahead and clone it now. But since we're talking about dependencies, just for the fun of it, I want to go ahead and start installing those. And we'll kind of start off with a demo. So to kind of give you an idea about what we're going to talk about, so like I said, Docker for local development environment. And the example we're going to use is this really basic app that we had built probably a year ago now. Actually, one of the guys who's no longer with us, he built this. It's almost like a glorified to-do list app. And kind of a way for us to get geared up with Angular 2 at the time. And so that's kind of been my fallback guinea pig. So I gave a talk back in May at the RVA.js meetup. And again, completely different topic, but that was my guinea pig. So today, it's going to, again, be our guinea pig. So it's a New Year's resolution app, pretty much a way for you to have a list of things you want to do better in the new year. So it is fitting to talk about those things in November rather than May, so that's good. I do want to give a shout out to Shaw, who is the guy who started that off for us, even though he's not here. You always need someone to kind of get the ball rolling, and so he did that for us, and so I'm thankful. Also want to give a shout out to my boss, Nick, here, who has been gracious as I experiment with some of these things that work. So a lot of what I'm going to share with you today is kind of the result of some things that I put in place for one of our projects at work. I have refined it a little bit, so you're actually going to see a better version than what we have at work, and then probably next week I'll go back and fix up what we have at work. So I mentioned that the example app we're going to look at is in Angular, Angular 4 now actually, but the kind of the basic ideas of what we're talking about can be applied to any language, so whether it's .NET and you have NuGet, or you're doing Go and you have your choice of many package managers, Python, whatever language you're working in, you're gonna have some kind of package manager, and Docker can help you out. Just out of curiosity, do we have any JavaScript people here? Okay, a couple. Java, anyone here? Java, .NET, Python. Yeah. What are if I haven't mentioned a language of choice, what do you guys do? Just I'm curious to hear from a few of you guys. Anything that I haven't mentioned? No. What's that? A little bit of everything. A little bit of everything. Awesome. That's cool. All right. So I'm going to take a break from that real quick. Let's go ahead and see if my app here is going to work. So I'm going to say npm run browser. Oh, and that didn't work out. So you know what it's telling me? It can't find the certain module right here. I could install this itself, but I kind of feel like, if I did the basic npm install, which is, hey, Node Package Manager, go get me everything that this project lists out, I feel like that should be there already. So you know what? If I look at my Git logs back at version 1.0, wow, some big changes. So maybe I should go back right before I did all those big changes. So I'll check out this version, I'll remove all those node modules, and I'll install them fresh. All right, so we'll pick back up after this finishes off, and we'll hope things work that time. Yeah, so a little bit about me. Like I said, I work for Unbox Technology. What we do is we do a mixture of things, but one of our software products that we've built in-house is a learning management system, so that's pretty cool. Doing pretty well these days. And then we have another kind of custom sales product that we also build out for some of our clients. And so I work on that sales tool, trying to kind of push things in more of the product direction. But it's pretty good for what it is. Now, I guess it would be good to kind of give you my background with Docker. So back in like June or July, I had a weekend, and I was like, I've got nothing to do. I've been hearing about this thing called Docker. So I just pretty much spent all weekend like watching Docker videos on Pluralsight. And that was kind of like my deep dive. And then from there, I started using it for some different use cases. So we've used it at work. We used it to orchestrate performance testing for one of our projects. That's pretty fun. I use it for a personal project to serve up a to host a REST API backend application. And then at work, you're going to see how are the main use case that we have for it. So that's me in Docker. Hopefully this install will finish soon. And just for some background, if any of you guys are not super familiar with JavaScript world, NPM, which is Node Package Manager, is the de facto standard, or pretty much is the standard these days for package management in JavaScript. There was this thing called Bower, but no one really uses that anymore. And pretty much there's only NPM, which is really nice, just having this one standard. Yeah. All right, it's finished. So let's go ahead again, see if this is going to work. All right, and we have some more errors. That's awesome. So I think what we can see from this initial example is, don't worry, the demo gods aren't against me. Like, I went through all this a couple days back, so that was supposed to happen, actually, believe it or not. But I think what we can just see from that is that we've probably all had days where our dependencies are against us. So maybe this is how you might spend some of your days. npm start, for those of you who don't know, is kind of the typical, like, hey, start off my application. All right. So as we can see, the problem is that dependencies are hard, okay? And so some of the common solutions to the problem is, okay, maybe you'll just rimwrap your dependencies directory, whatever it might be, node modules or whatever, and just reinstall them and give that a try and just kind of hope it works, as I did there, and it didn't work. Another option might be, after you've just kind of mangled your project, is just, what, let me just back up one level. Let me just kill that whole directory, and I'll just clone it again from source control, and I'll just start all over again. I'll start fresh. Sometimes I've done that. Sometimes that works. Sometimes it doesn't work so much. Another potential solution is, okay, update your global versions of whether it's your language runtime or your compiler. Sometimes that works. That might solve the problem that you're having with that particular project. But if you have multiple projects running on your machine that all use, expect a particular version of Node or .NET or whatever it is, well, if you update that for just one project, you might end up breaking other projects. So again, sometimes you can do that and you're safe. Sometimes you do that and you fix one thing and break the other, and that's not a very nice outcome as well. And sometimes you just say, well, screw it. If it's something that you're just doing on your own, you have the option of just walking away and just quitting completely. You don't have that option at work, but sometimes if you're on your own, it's just nice to go with that. But all of these solutions have kind of their drawbacks. So we're going to take a look at how Docker can help us out. So when we talk about dependencies, just real quickly, there's, it can mean a couple different things. So we can have system level dependencies. So maybe it's my operating system, my compiler, the CLI tools that I have, language version, runtime version, etc. Maybe even your browser in some cases. If you're testing, can be a system level dependency. And so we have kind of this overall higher level of things, and we'll see how Docker can help us, get these things fine-tuned for the exact environment that we need. But even without Docker, you should really ask yourself, okay, I'm about to install this thing. Does this really need to be a system-level global dependency? These days, it's pretty common in the Node.js world just to, hey, let's just install this cool new CLI. We'll install it globally, and it'll all be great. The G flag there, in case you're not familiar, is, hey, install this globally. And again, with or without Docker, there's ways to avoid that. And just installing everything globally, it has its problems. But then we also have project-specific dependencies. You might have the same set of dependencies, but all the dependencies of themselves have different versions, right? So you might have, in my world, we had Angular 2 at one point, and now it's at Angular 4, and you can't really go back and forth unless you just, rip out your Node modules and reinstall everything. What's that?
Dependency of JRE version, specific JRE version.
Yeah. So it could be anything, right? And these days especially, a lot of things are open source. Our languages are open source. Our dependencies are open source. Even some of us have open source operating systems. And so you kind of end up with this massive open source smorgasbord, and you're kind of stuck with trying to make everything work, and you just end up with a lot of headaches at some points. So a little bit of context. I already mentioned briefly about JavaScript. So in case you're not familiar with that, the package manager we're going to use is called NPM, which is Node Package Manager. When you install your dependencies, it goes in this folder called Node Modules. Package.json is the file that describes, all the metadata for the project. So here's the dependencies, here's my version, and different package managers have kind of a similar idea. Hey, there's this one file, and that describes all the stuff about this project. We have NPM scripts, which you'll probably get a little taste of because we'll use some of those. It's pretty much a way that NPM kind of acts as a task runner for you, which is pretty convenient. Any questions so far? No? Okay. I think I'm explaining things that we've all had some level of familiarity with. Is there anyone here who's not touched Docker before? It's okay. We're all there. Okay. There's probably more than just one, but you're afraid, and then nothing wrong with that. So in case you haven't seen Docker, in 30 seconds, how I would describe it is Docker is a virtualization technology that allows you to create isolated, minimalistic environments configured with only the absolute necessary dependencies needed for a specific purpose. John, is that how, if you had to explain Docker in one sentence, is that how you would explain it? Or am I a little bit off?
No, it sounds pretty good.
Okay, good. All right, so if you don't know what it is, what is a container? A container is that environment, that runtime that you set up. It's the easiest way to explain it is almost like a super small, super lightweight virtual machine that has just the bare minimum dependencies that you need. The concept of an image is also very important because it's mostly what we're going to look at today. An image is, in operating systems world, the image is kind of what describes all the file system and everything of your operating system. So in the container world, the idea of an image is pretty synonymous. So the image is almost like saying, hey, this is what my environment should look like, and then a container is just an instance of that image. If you've, again, touched Docker in any way, you've already done this. So we'll move on. But wait, you might be thinking, well, you're talking about managing dependencies better, but if we bring in Docker, isn't that just another dependency? And to answer that question, yes, it is. Technically, yeah, it's another dependency, but it's going to really help us manage and really kind of lock in all the other dependencies that we have. So instead of having 20, 30, 100 dependencies, we have essentially one that we have to worry about from day to day. And of course, even Docker has different versions. So if you needed to, I've read about it, but you can actually run your app in Docker that's running inside of Docker. And it might be hairy, but you can do it. And you might be thinking, what, Docker inside of Docker inside of Docker? It'd be kind of interesting to see how far we could take that. I was pretty mind blown when I read that you could actually do that. That's next on the list of things to try. All right. And also, I kind of want to point this out, that using Docker for our dependencies, technically it doesn't solve our problem. It helps prevent the problems that we would have. And again, what I'm about to show you guys, I don't think it's healthy to be dogmatic about anything in the world of technology because there's multiple ways to skin a cat. or skin potatoes if you're not into skinning cats. And so, what I'm going to show you is just a way that you can solve these problems. Later on, I'd be interested to hear from you guys on, how you've solved similar problems, maybe how you could kind of take what I show and improve further upon it. That'd be, I think, an interesting conversation to have. But without further ado, let's jump away from the slides for some time and actually look at the image that we're going to build for our environment. Let's see. So I'm going to look here in, oh, you know what? It would be helpful if I had the most recent version, huh? Check that out. All right. So I'm going to look inside here. So starting off, this is a Docker file which tells Docker how to build my images. So we're going to look at, okay, first case, how I can build an image that will create that environment that will help me develop locally. So this is actually a super quick and dirty example. We're going to step through. There's 4 iterations we're going to look at, starting simpler, and then the last one's going to be the polished version. But so if you're kind of just testing it out, getting up and running quickly, this is like the basic version that you would do. So you can kind of go in here and say, all right, let me set environment variable, tell Node that I'm running in development environment. First off, I'm just going to make a directory here to put all my stuff in. I'll set that app directory as my working directory. And then I'm just going to take everything that I sent to my build context to Docker, which says, okay, that's all the stuff that you give Docker access to. And I'm just going to say, okay, all that stuff that I gave you, Docker, you just throw it in there inside of the app, which is not good. Don't do that. If you do that, at least have a Docker ignore file, which is kind of the git ignore of the Docker world. It says, okay, Docker, you can't touch these things. So I did at least have a Docker ignore file. So there wasn't a lot ending up in here, but still, it's better to be explicit about the things that you're sticking inside of your containers. And then after that, I'm just going to say, all right, well, I know that my package.json ended up here in my app directory. So let me just install those things. And then I'll expose these ports right here because when I'm developing with Ionic locally, it needs those ports to serve and then for the live reloading here. So if I had built this image, and actually this is where I started with a while back, then I could run my app like this. So I can just say Docker run, and then interactive, I want to open up these ports right here. And then right here what I'm doing is I would go ahead and map my local source directory to the source directory inside of the app directory inside of my container. So right there, in case you haven't seen it, that's using volumes. So I said, okay, hey Docker, I'm going to let you look at this directory that's on my machine, and you can have access to that inside of the container as well. And then this was the name of the image that I called it. And then this was the command that I wanted to start up my image with, or start up my container with, which was the command that I was trying to run earlier that didn't work. So if you're just getting started and trying to build out your environment like this, this is at least a starting point, but there's a lot of problems with this. Just before I move on to the next version, any questions about what we're seeing here? Yeah.
What version of Docker are you?
It's 17, I can actually answer that question. There you go. So 17.09. Yeah. Any other questions? Yeah.
I noticed that there's not a CMD or an entry point in this Docker file, so how does that work?
You know what, I'm glad you asked that. So since there's no CMD or entry point, I had to give it this command to start the container off with, right? But in the next version, we get a little smarter and we say, you know what, let's go ahead and add an entry point just to make it easier to start off that container and to make the container a little more specific in its purposes. So a great segue. I'll give you your 20 later on. Yeah. You have a question?
Yeah, I mentioned you said something about running Docker within Docker, right? Is that best practice or?
Probably not.
Yeah, in my instance, right, you would have a Red Hat image.
Yeah.
You might have a Jenkins instance running within a container.
Right.
But you want to take that container and configure it to use the Docker Docker socket and it's
Right.
available on the
Right.
host, correct?
Yeah, I'm gonna stop you there. So it was I was kind of pointing out that you can do it. Definitely not condoning that. And
Okay.
like I said, I have not tried that. I just know you can. So yeah. All right. So moving on. This version really isn't that much different from the last version. So what we added was we added this entry point here. And then when you're building out your images, right, like each layer of the image is itself an image. And so what Docker does, as most of you probably know that when Docker's building out that image for you, it sees, well, hey, if this layer here already exists, then I'll just reuse that. I don't need to rebuild that, right? So that means, well, back over here, if there's a layer that already exists that has all those dependencies that I installed, it doesn't need to reinstall every single time, right? So right here, if anything from my project changes, then that means, okay, the very next step will have to be rebuilt, right? Because as soon as Docker sees, okay, this level doesn't exist in the cache, everything that comes after that, I've got to rebuild that, right? So at least over here in this second version, we can prevent that from happening. So we just start off with our empty directory, set that to our working directory, and then first off, we put only our package.json inside of our directory. And then we go ahead and run npm install and just get all of our dependencies. So that means if anything inside of here changes, we can, as long as our dependencies haven't changed here, then we can just go ahead and reuse those every time we have to build a new image. And our image builds are going to be much, much quicker. But yeah, so besides that, nothing else has changed from the last time. Any questions about this guy here?
Can you go over what you just said? The package JSON doesn't change, so why? I don't understand, why is your builds going to be faster?
Right. So anytime so let's say I build an image for version 1 of the app, and it has a certain set of dependencies, right? So when I build, let's say I build the image with this Docker file, then when that package.json goes inside of in the image, and it installs, right? So then if I need to go and build like version 1.1 of the application, I need to build an image for that version. Well, if the package.json file, if my dependencies haven't changed, then it doesn't need to, so Docker can just use what it already built out and what's already existing in the cache. It doesn't need to, since it says, okay, well, this didn't change, so that means I can just reuse that. And then since if package.json had changed, then every step after this would have had to be rerun. That means I would have had to reinstall all my dependencies, which would have taken a long time. So since package.json didn't change, I said, okay, I can reuse that. And then the very next step, it'll again check and see if that layer already exists in the cache. Well, the dependencies didn't change, so it knows, okay, well, guess what? All these are also already existing in the cache. And then it can go through much more quicker.
So it basically examines the image previous to that and then notices that these layers were the same.
Yeah.
And appends it to it, right?
Exactly, yeah.
Okay.
Yeah, so you can just reuse the work that you already did, essentially.
How does Node Package Manager know to check cache from the previous image?
So Node Package Manager knows nothing about Docker, right? So the caching that I'm referring to is when Docker is building your image for each, so like essentially each line of the Docker file builds a new layer of the image, right? And so if it's already built one layer, then it's not going to rebuild it, right? So if we only had this to start off with, right, and then maybe I was building this image multiple times, it wouldn't ever need to redo this because it said, okay, well, I already did that. Let me just reuse what I already did. Does that make sense?
Kind of new to Docker.
Kind of? Okay. Yeah. But so, yeah, I mean, that's one of the main benefits of Docker is that, so long as nothing has changed, it knows, okay, I don't need to go through this step again. It does that for each line. Yeah.
One thing I might add is this kind of highlights a best practice of creating Docker files. Each layer builds on all of the layers previous to it.
Right.
So when you're building a Docker file, put the lines that change the most frequently near the bottom.
Exactly.
And every time you rebuild, you're changing it, you're reusing all those layers, like
Yeah.
you're saying. But if you put like that line at the beginning, then you're invalidating everything every single time.
Exactly. Yeah.
So, John, if I could ask, if you are building an image that way, and you do have, the first 10 steps, and you solidify that, right? You want to inherit that from a base image, and then add to it command-wise?
You could do that.
Okay.
Yeah.
A little bit more.
Yeah, Joe, that's a great point. I was actually going to get to that, so thanks for beating me to the punch. So yeah, but so I think the main takeaway we can get from this version is that, okay, just by kind of rearranging the order in which we add things to our image can make our builds much faster, much more efficient, and we don't have to redo work that we've already done. But there's still issues, I would say, at least with this. So I still don't want to use this one. But before we move on, any questions about this version of our Docker file? Yeah.
Expose never changes either, but that's something that's happened beyond. I guess there's something that's going on.
What's that? I'm sorry.
The exposed reports, I don't think those.
Yeah, that's never going to change, right? But again, like if anything before it changes, then all the remaining layers are invalidated and have to be rebuilt. If you've got to rerun this one step, like, it takes like a millisecond, so it's not a big deal. But
That's like a metadata step, really.
yeah, but it's steps like this, like install my dependencies, build stuff. That's the kind of stuff that you want to keep from changing as often as possible. Yeah.
And you're giving it a name actually, right? If you're going to automate it or something like that, don't you want to have to tear down actually if an instance is already running or something like that? Because you're rebuilding and then you're creating a new instance, right? The image.
So if you're talking, are you talking about starting up a container based on this image?
Yeah, because you give a name, right? Unbox technology or something like that.
Yeah.
So as you execute this twice in a row, what happens actually?
Yeah, so this right here would be the command to start a container from this image. And so we are...
You're going to change it every time, right?
Yeah, so we're assuming that, okay, I called my image unbox.technology/New Year's resolutions. And so we're actually next going to look at how to manage versioning your images. So that way, okay, if I'm on version 1.1.0 of the app, I check out, or I pull version 1.1 of the Docker image. But if you don't specify a version or a tag when you build the image, then it's just tagged as latest. And then each time you build latest, it overwrites the previous latest version. So again, don't take this one to the bank. It's just a starting point.
I have a question.
Yeah.
You're mounting the working directory source folder in the app source.
Yes.
Then what is add dot/app doing?
So again, that's just saying, hey, like, if there's anything in there, just stick it in there. So like, there's some other like higher level project files that are needed, and so those are going in there. But again, actually, I'm going to get rid of this step in the next version because all this does is say, hey, anything that's in my working directory here that I've given to Docker, as long as it's not in the Docker ignore, just stuff it in there. So it's just saying, hey, just put it all in there, right? And you don't really want to do that. Yeah, so just putting everything else in there. All right, so now let's look at version 3, and we'll kind of park on this one because there's a lot of changes in the third version. All right, so this version you could actually use for your local development. First 3 lines, nothing changed. I threw this in there, so right here, the node image is based on, I think, a Debian image. So right here, I'm saying, okay, like if there's any like system level tools that I plan on using, then that aren't going to change. Let me go ahead and kind of get those taken care of at the beginning. I'm not actually going to use this at all. This is for like if you need to FTP your build files to your server. But we do use this in the real world. But I won't use it for today. Just threw it in there for an example. If you have your system level tools that you need to update or install, go ahead and take care of those at the beginning. Next, I'm going to go ahead and install my Node modules. So this stuff is the same. Right here, I'm being much more specific about exactly what I want to go inside of my image. So I'm saying, okay, hey, take this file that I'm calling dependencies.json and stick it inside the image, but when you put it inside there, call it package.json. And we're going to look at in a few minutes what this exactly is. But when you're using, the next step is npm install, right? So it's expecting there to be a package.json file in there so it can read, okay, install these things. But we'll talk about why exactly I did this here. So I went ahead and installed that. I need to install these global things here in my environment to get up and running. There's another dependency that we use for our project. It's an Ionic project, which kind of is built on top of Cordova. So pretty high level stuff, and it wraps, some lower level stuff. So if you need to, so we have to build like a Cordova platform. If you're not familiar with Cordova, you can just throw that out the window. But it's just an additional dependency that I need that's going to come after Node modules. All right. Now right here, what's happening is I'm adding another file that I'm also saying, okay, put that inside my environment, but call that package.json as well. So actually, what ends up happening is this dependencies scripts file is going to end up replacing this dependencies file that I put in there previously. And then we go through, and the reason why I did that is because this has some knowledge. It replaces, yeah. So it's going to, since I said, okay, put it in there exactly as package.json the first time, and then I'm putting in a different file as package.json, it's just going to override it. Yeah. And I need this version exactly so that I can run some scripts. Goes through, and I'm going to, pretty much all I'm doing here is just adding some higher level scripts and config files that I need to actually get up and running with the application. So the major change here is that, okay, one, I'm not just willy-nilly just stuffing it all in there. I'm being very specific about, okay, I want these files and these files only inside of my image. Now, a problem that we have with the package.json file is that file itself explains a lot of things besides just your dependencies, right? So your version number for your project also lives in your package.json file, right? So if we look back at the second version, let's say nothing about my package.json file changed. I'll just go ahead and show you because you haven't seen it. So yeah, right here I've got my version up here, right? So all the rest of my dependencies here could have been the same, okay? But if even my version number changes, well then guess what? Back here in version 2, well, my dependencies didn't change in this file, but something changed. And so Docker says, well, you've got to go ahead and install your dependencies all over again, right? So if you want to build an image for each version of your app, well, you're going to end up installing your dependencies for each version of the app, which is kind of defeats the purpose of using Docker anyways, right? So what I did was, and you can check out the nitty-gritty details later if you're interested. Let's see. So first off, dependencies.json. All that is this file right here. It's only, okay, just my dependencies and some additional metadata that's related to my dependencies. But this is pretty much, this section right here is kind of like the meat and potatoes of this file. And what I did was, in my version bump script, I said, okay, right before you commit the change, go ahead and just strip out all of the commonly changing information from my package.json and go ahead and save that locally, right? That way, Docker is only looking at this file to install its dependencies, right? So there's no version number in this that's gonna be changing every time. And so I know that only if and only if there is a change in my dependencies will my Docker image have to reinstall, right? So that's the purpose of that. And then at the same time that I create this file, I'm also creating this file, which has all the stuff from before, but also just the basic scripts that I need to actually do an additional dependency step and actually run the application itself. So like this one right here, we have to like do some crazy stuff with Cordova platforms to get it working just how we want it. So again, that's just an additional dependency step. But I need, let's see. So this guy right here, add platforms. I end up running that right here, which is why I have to add this version that has both dependencies and scripts. And these files right here, they're just Ionics and Cordova specific files. Don't put any stock in these, but these have to be there in order for this to happen. All right. So what we can see from this one is, okay, ideally you'd be your development environment would be automated. And so, as you're bumping your versions, each time you build a Docker image, you can get a lot of reuse by using, stripped down versions of that dependencies file. Now, I want to go into a little more detail about this one and how it kind of works in the environment, but before, I want to just kind of touch on a few of the scripts that are working together to make all this happen. But any questions first about this Docker file specifically?
I'm just a little bit confused about the functional benefit of separately calling the docker/dependencies.json and then you have to get dependencies-scripts.
Yeah.
Is there really any functional difference between having that two different files?
This is a great question. I mean, technically, it wouldn't be the end of the world if I just put the scripts in at the beginning. But think about it. If, let's see, this guy right here, dependencies, also has scripts. And those scripts, if they don't have anything to do with me installing my dependencies, if there's a change in even one of those scripts, well then, when I get to this point right here, if this guy had scripts that changed, then I'm going to have to reinstall my dependencies. Even if my dependencies didn't change, they're just any change in that file, I've got to reinstall.
So when npm runs, it's only installing the delta between those files. It's not reinstalling things that are the same.
No, so npm doesn't know anything about cached packages, knows nothing about that. npm is not smart. Yeah, so Docker knows, right? So each time if this runs, it's going to install everything. But the value is, okay, I want to keep this file right here from changing at all, so that way it doesn't invalidate the rest of the levels of the image. So when I get here, well, if this hasn't changed, then I can reuse this. And I don't want things external to my dependencies causing me to reinstall my dependencies. Yeah, that's a great question. Yeah.
It seems like I get the. It seems like you're definitely saving a lot of time.
Yeah.
The npm install can take a while.
Yes.
But now you have two files that you have to manage. So how does that? Do you have a script or something that automatically generates your dependencies?
Yeah. So actually, that's where I was going next.
Second master.
Yeah, there you go. Yeah, we met and we talked about all this. I'm gonna finish this question before I get to you. I'm not gonna go into super heavy detail with this because a lot of it is a little more JavaScript specific. And again, you can kind of look at the details of it later, so I don't want to spend too much time on it. But what ends up happening is if I want to bump the version of my project, then I'm going to do npm run bump. Or sorry, I'm going to do npm run. We'll just look at patch, for example. And so then that comes up here, and that runs the bump script with the patch argument. So then I'll go over here and look at the bump script. So the bump script here is kind of what ties all the pieces together, automating kind of these intermediary dependency files, making sure that versions on different files are staying in sync. So first thing I do is I say, okay, let me go ahead and get the previous version of the project. I'm going to export that to my environment because there's some other scripts that are going to follow that need that. This is just an npm script that you get by default that updates this version number here for you. These right here are what manage syncing all the files. So this guy right here is not Docker specific. So we have this config file, and all that does is just updates the version number in this file. Nothing special. Sync pipeline here actually. So we'll actually get to this later, but preview is we use Bitbucket pipelines for CI builds, and so this script right here makes sure that the file that describes how my build steps is always starting with the most or with the right version of the image for my project. But again, more details on that later. Don't get too hung up on this guy. Copy dependencies is what goes through package.json and strips out all the unnecessary stuff and saves those specific versions. Again, just kind of like basic stuff. And then after all that happens, so we went through these scripts right here. So I made sure that version numbers are same across the board. I went through and I stuck these guys in here. And now I'm ready to build my new image. And so again, this happens on every version bump, right? Before I look at what happens here, any questions about what we've seen in this script so far? Yeah, it's pretty kind of basic stuff. So if we look at npm run docker build, which goes off and says, all right, I want to run this here. All it does is it gets the current version. Excuse me. And then it goes ahead and it builds a new version of my image. So I'm going to build it. I'm going to tag it. Here's my tag name right here. And then for the version, it's going to use the new and updated version that I just bumped to. And so the value of this is, you might have version 1, version 1.1, version 1.1.1. And so if you do this for every single version change, whether it's major, minor, or just a patch, you're going to end up with an image for each of those versions. And you might think, well, that seems kind of like overkill. But one, it's not really, because if nothing changed, then that build's going to go really fast, right? Because if dependencies haven't changed, then it's just going to be a quick build, push it, and we're done. And no worries. However, if your dependencies have changed, and let's say you need to check out, maybe version 0 that you haven't touched in 6 months. Well, if you have a Docker image that's versioned for that version of your application, well, when you check out that version of your code, you just pull down that image, and okay, I've already got the dependencies that I need here. So again, it seems like overkill building each time we bump the version, but it has the potential to save you lots of headache in the future. Any questions about that automation process that we just looked at?
So you can do a new build, it creates a tag with the latest too?
Yeah. So that way it's not overwriting previous versions. I can keep all those versions together and just use whichever one I want at a specific time. Yeah. Yes, sir.
You said earlier this doesn't exactly solve your problem, but it makes it easier. What problems does this pose?
So for one, if like the projects that I work on by myself, and even at work, there's like maybe 2 on a project. No issues really, but I could foresee that, okay, if you are, on a larger team and you've got, people on the same or similar versions, like working really fast all together at the same time, you might end up with, okay, let's say so-and-so is, maybe you've got 2 people out of a team of, a lot more. Maybe they're both on version 3, okay, and they're building their own feature. All right, well, if the first guy says, okay, let me commit this version bump 3.0.1, and he builds an image and then pushes it, and then he pushes his changes to source control, and then the second guy comes right in behind him and does the same thing. Well, what the second guy just pushed to Docker Hub is going to overwrite what the first guy just pushed. So that is a potential problem that I haven't thought about how to solve quite yet, because honestly I don't have that problem because there's two of us. But yeah, it definitely is a problem if you're working on a larger team. Git's cool because it's not going to let you push 3.0.1 if that already exists. But with Docker, you don't have that protection built in. I mean, one way, just right off the bat, you could probably do that is just go ahead and try to pull the next version that you're about to build, and say, well, guess what? If that pull fails, then that means okay, I'm clear to go ahead and build this and push it. And then if you're expecting there not to be a version 3.0.1, but yet you get an image, well, then you just dump the script, say, hey, you got some conflicts, you got to work it out. Yeah, good question. Any other questions about this process? I know it's kind of like nitty-gritty details, but what's that?
How the $version is referring your third Docker file? Yes, my ask is, you have mentioned to build based on, you gave the variables, right? $version. How it refers to your third version of Docker file?
Oh yeah, so if I understand you right, so like this is just the version of my project. It's just reading, this script just goes through and it reads the version right here. We're looking at different versions of Docker files. Ideally, you wouldn't have that in your, in the real world. I'm doing that so we can kind of look at each one in iterations to kind of see how we go from point A to point B. But yeah, so this would just be using, my standard Docker file here. These are all examples that I'm not actually using. Was that your question?
Yeah, so you have the third, this is the third file, right? Third Docker file. Where you have mentioned it as a third pass.
Are you talking about this one? Yeah.
So is that file, the other file, is referring to this file?
So when you issue, that's okay. I'm just your question now. So let's go back here. So when you issue this command, yeah, so I'm not telling Docker which file to use.
Okay.
So when you run this command, by default, it looks in the root level of your project, and it's going to look for a file called just Docker file. I don't know if it checks for case, but if it sees this and says, okay, I'm going to go ahead and use this, you can specify a different version by passing in a .f and then path to Docker file. You can do that. But yeah, so since I'm not specifying a specific file to use, I'm just going to use this one, which is what I actually use for the builds. Does that answer your question?
Yes.
Yeah.
Can you open the Docker file once?
This one?
No, the one you said that it will refer to that Docker file.
Yeah, this one?
Yeah, this one.
Yeah. So if there's actually, this is what we're going to move on to next. So if there's no questions about the previous images that we've built, there's no questions about the automation process or the scripts that we looked at. Any other questions before we move on? No? Okay. So again, like there's a lot of talking, a lot of code, and we're not actually running anything, but we're going to look at some improvements that we made with this last one, and then we'll actually go ahead and see, okay, does it actually work? All right, so let me open up this one and the last version. So you'll notice there aren't a ton of changes between this version and the last version, because the last version already had some good optimizations with stripping out all the changing information from my dependencies file and making sure we're not reinstalling dependencies if we don't need to. But there is this last step here at the end. So this is just like some scripts, Webpack, which explains how my application code is going to be built, and then some basic stuff that TypeScript needs in order to actually run the project. So again, this is just kind of like more like high-level stuff. And then I went and just for kicks, I just put the final version of package.json in just for the heck of it. But actually, we don't really need all these right here, because if I'm only using this image to start up containers for my local environment, then I can actually just use volume mounts to plug all these things in at the time that I start up my container, rather than storing them in the container, in the image itself, right? Because these files are all in version control, so I don't need to keep track of them in my Docker images as well.
So volume is like external, something external from the image to access on the system.
Yeah, so when you, so for example, when we are doing this right here, we're saying when I'm starting up the container, when I pass this volume argument here, that's saying, okay, I'm taking the source directory from my machine, and I'm saying, all right, Docker, when you start this container, the container can have access to this stuff from the outside world, and the container, it's going to see it as this right here. So you're like plugging things into Docker containers that exist on your local machine. Yeah.
In a sense, if you were using this and scaling, for example, you would essentially be plugging into that so you could keep scaling and adding more containers.
Yeah. What do you mean exactly?
Well, meaning if you had an application that was running in 2 containers, but you wanted 3, 4, 5, you're on your local machine, you're going to kind of leverage that to keep building the same container so you can access the same amount of volume from the information.
Right, exactly. Yeah.
Is that for instance, curious.
What's that?
So you were actually saying 3 containers accessing the file system in the same place.
Mhm.
Managed so that it wasn't overwriting each other.
Yeah, so I mean, you can control like read and write access. So in this case, if your containers only need to read, then no problems, right? You can have however many containers you want reading the same files. I haven't really gotten into the case where I would have multiple files or multiple containers that are changing the same location in my file system. I can't think of a use case where that would happen, but I'm sure there is. And then, there would be some heavy lifting figuring out, okay, who gets access, who doesn't. Yeah. But for our purposes, we're just saying, okay, you can read this stuff. All right. So the new Docker file is pretty much the same as what we've already seen, except we don't have this stuff at the end. The difference is, let's see, go to scripts, Docker start. So let's say I've taken this image, or I've taken this Docker file, and I've built an image with this Docker file. If I now want to kick off a container based on this image, here is the command that I would use to make sure that the container itself has access to everything it needs and to be able to get started. So before, I was mapping the source directory from my local machine into the source directory in the container. And then I'm just going to do the same thing for Webpack, because it needs Webpack to build and keep rebuilding for development. And then it's a TypeScript project, so it needs these high-level files right here. And then what ends up happening is I actually didn't even need to stick the full version of package.json inside of the image itself, because once I get this container up and running, which we'll do in just a second, it's just started off with that one process, right? Like it doesn't need to see any new things that are in the package.json file, because it already has what it needs, so I'm not going to give it anything that it doesn't need. So now we've done all this talk. It'd be nice to see if, okay, does it actually work? But before we do that, any other questions?
We're ready for the demo.
All right, the moment of truth. So we've already seen some failed demos. All right. Yeah, so we're going to look at actually a couple different demos. So the first thing is, okay, does it actually work? So we will come over here. All right. Just so you know, so I'm on the most recent version of this project. We'll look at what I've got here in my Docker images. So this image right here I've already built and I have it locally, right? So I'm going to go ahead and run npm start, which is a typical startup command for Node projects. And I'm going to show you what it's going to do. So npm start here. Oh yeah, it goes and runs docker start. So all it's going to do is it's going to run docker pull, which is a script that just makes sure that we have the most recent version, or the version that corresponds to the version number in package.json. And then it's going to go ahead and kick it off, right? So we're going to run this script and see if it works. Oh, you know what? I guess.
This 1.4.0 is already there, right?
Yeah. So it's building all that stuff. What was all this? All right. So it's building it. Cool. So now we will see if it works. And it works! Happy New Year, guys. It works. All right. So like I said, the app is nothing special to write home about, so I'm not going to do anything inside the app. But just to show you the benefit of this is, so we opened up all those ports so that, one, it could actually serve the project, and then secondly, for live reloading to work, right? So if I go in here, let's change something. Let's see here. If I change, I've not looked at these files in a while. Pages. All right. Shoot, I don't even know what I want to change. It's a problem. Let's just go ahead and change something basic because we can. Just change the title. That was not very exciting. So change that, rebuilt, and oh, well, maybe it's because, yeah, let's actually change something real.
I don't think syncs that.
Do what?
It syncs it.
Oh, yeah. Dang it. You know what? If we change, all right, so this is what I'll do. So if we open up this menu and hit enable dark mode, everything goes dark. So I'm going to change that dark to blaring red, just to prove that it works. All right, so you can see, okay, rebuilt. Come in here, open up the menu, and that's a bit scary, but okay, it worked. All right. Now, another use for this is, let's say, okay, I've got an older version of the app, and maybe version 0, we released that 6 months back. I haven't touched it since. But then, let's say some well-meaning user is trying to set up their New Year's resolutions, and they report a bug. So I'm like, oh crap, I better go fix that, right? So let's take a look here at version 0 here. So I see someone named Hayden Braxton said they call it an undocumented feature. I wonder what that must mean. So let's go ahead and see if we can fix that. So if I check out this version right here, now it's important to point out that the dependencies for this version have completely changed. So it's on older versions of Angular, older versions of Ionic. Pretty much all the dependencies are different. So if I just run npm start, it's going to go ahead and pull that new image. All right. Okay, so this is the old version, and if we open up the menu, well, some developer got smart here, and they thought it might be fun to stick a dancing banana in the app, but I don't think users would appreciate that. So, I could just kind of go in on that version, make that quick fix, rebuild, 0.1.2 that doesn't have the dancing banana, and then all is well. But, if developers would just be a little more responsible and not fool around with their projects, we wouldn't have these problems. But if the problem happens, you have a bug on an older version, and it could be a legitimate bug. And maybe the legitimate bug is related to dancing banana, or maybe it's not. But whatever that old bug is, you can go back and you can fix that easily enough, right? All right. Another, couple of like good use cases for this is like if you need to experiment with something, you can kind of go crazy and just kind of run it inside of your containers, and you're not gonna have any problems. You can kind of go crazy and not worry about messing anything up on your local machine. Now, any questions about what we saw there?
Yeah. So the live reloading.
Yeah.
Maybe you already explained this, but that's why you mount the code into the image. Right?
Well, I mount the code inside of the image because it needs something to run, right?
Yeah.
But so when it runs inside of the container, then the live reloading is working on these other ports to let your browser know, hey, I've got a new version. Go ahead and refresh.
But when you changed your code in your IDE, you changed it locally,
Yeah, I change it locally in my IDE.
and that reflects changes inside of your container.
Yes, flex changes inside the container. Thanks for feeding me that point. That was good. Yeah. So yeah, I mean, it made changes inside of the container that was running because it was looking at what I had on my machine, and then since I opened up those ports, it was able to tell the browser, hey, refresh. We've got something new. Yeah. All right. Before we wrap up, I need a volunteer.